Hello, we are Team 102. I'm Travis Adams. My fellow team members are Grace Armfield, Jordan Goldstein, Chanel Miller, Michael Michella, and Ethan Rowland. And our project is the Capital One Neighborhood Pulse application.
Capital One has recently started the Capital One Cafe program. These cafes are an alternative to traditional banking branches. They emphasize the customer experience and aim to build strong interpersonal relationships between customers and employees. These employees are called cafe ambassadors. Sometimes these ambassadors have difficulty connecting with customers because they don't know enough about the local area. Our application aims to help these ambassadors by providing information about local events in the cafe's neighborhood.
For our first sprint, we really wanted to get the fundamentals of our three different systems built in a proof of concept stage that we could extend upon later. To this end, we wanted to build a basic proof of concept front end, a basic proof of concept back end that can serve data from our database to that front end, and finally have a database set up and populated with data that was scraped by one of the web crawlers that is currently reading from one source. We were able to accomplish all three of these goals for this sprint.
So, for our POC front end, we decided on TypeScript React because it's strongly typed and modern. For our user interface for this front end, we chose Material UI because it's clean and simple and very popular. And now, to actually render our map, we're using the Google Maps JavaScript API. And to retrieve the events that we render on the map, the front end makes an HTTP GET request to the back end.
The back end of our application is built using Java Spring, specifically Java Spring Boot. It uses the REST principles to serve data to the front end upon receiving an HTTP request. It connects to our database using the Spring Data JPA with a CRUD-style access scheme for creation, reading, updating, and deleting from that database.
In order to actually get this information into the database, we use what's called the Beautiful Soup Web API. This is an extension to Python that's very popular for the purposes of web scraping. In order to actually scrape the website that we're focusing on, which is atlanta.net, we first open up the website in Python, iterate through the various parts of the HTML web page, and extract attributes such as name, description, event type, or location. Once we have this location, we then pass in the address and location information into the Google Maps API in order to convert that address information into latitude and longitude coordinate points. Once we have those coordinate points and all the other information packaged together, we then upload this information into the SQL database for use by later parts of the program.
Not only did we want to build all of these separate parts of our application, we also wanted to make sure that they worked together. To do that, we needed to deploy them somewhere that we could use for testing, demoing, and other interactions. We chose to use Amazon Web Services. The front end and back end are each deployed separately into AWS EC2 instances. The database is a MySQL database running within Amazon Web Services relational database service. We're now going to move on to a live demo of our application. Here you can see I've opened up just my web browser. I am now going to navigate to the IP address of our current EC2 instance on port 3000 that is hosting our front end.
As this page loads, the front end that we designed sends an HTTP GET request to the back end in order to retrieve the events that you see displayed here.
The back end is receiving those requests, routing them to the proper section of the code that will handle that type of request, and then returning a list of events as a JSON document from our database.
This concludes our demo video for Sprint 1. Thank you for watching.